All right, in this lesson, we're going to convert from polar coordinates to rectangular coordinates. So let's start with some point on a plane. And to describe that point in rectangular coordinates, we're first going to go over a certain amount in the x direction. Call that x. And then we're going to go up a certain amount, and that's y. And that's how we would describe that point. Go over x, and then this is going to be perpendicular, so that's going to be a right angle, and then we're going to go up y. That's how we would describe for rectangular coordinates. Now for polar coordinates, we're going to go straight out from the origin out to this point, and we call that distance r. And then we want to know the angle from this polar axis up to that line, and we call that theta. So now notice that we've got this triangle here with r, theta, x, and y. And so we should be able to use what we know about trigonometry and the Pythagorean theorem to figure out how to convert between polar coordinates and rectangular coordinates. So let's start with going from polar to rectangular. So if we are in polar coordinates, we know r and theta, and we're trying to figure out x and y. So if we know, let's start with x. If we know r and theta, and we're trying to find x, well, we know the angle, we know the hypotenuse of this right triangle, and we're trying to find the adjacent side. So adjacent and hypotenuse, that tells us that we're going to want to use cosine. So the cosine of this angle theta is going to be equal to the adjacent side, which is x, over the hypotenuse, which is r. And now if we solve for x by multiplying both sides by r, then those r's will cancel and we get that x is equal to r times the cosine of theta. So that's going to be one of the equations that we use to convert from polar coordinates to rectangular coordinates. Now let's figure out y. Well, y is the opposite side. So if we know the angle, we know the opposite side, and we know the hypotenuse, or we know the angle and the hypotenuse, and we're trying to find the opposite side, then we know that the sine of that angle is going to be equal to the length of the opposite side, which is y, over the length of the hypotenuse, which is r. And if we multiply both sides by r again, we get that y is equal to r times the sine of theta. So those two equations are the two equations that we're going to use if we know r and theta and we're trying to find x and y. So let's do an example here. Let's say that our point is 4 pi over 6. That's our point in polar coordinates. We want to convert this into rectangular coordinates. Well, the r is 4 and the theta is pi over 6. So x is going to be equal to r, which is 4, times the cosine of pi over 6. And y is going to be equal to 4 times the sine of pi over 6. And then we can pull out the unit circle and see that the cosine of pi over 6 is square root of 3 over 2. So this is going to be equal to 4 times the square root of 3 over 2. And the sine of pi over 6 is 1/2. So this is equal to 4 times 1/2. And then 4 times the square root of 2, or 4 times the square root of 3 over 2, this 4 and this 2 will reduce down to 1 and 2. So this is 2 square root of 3. And then 4 times 1/2 is equal to 2. So this point in polar coordinates is equal to the point 2 square root of 3, 2 in rectangular coordinates.